When installing a motor Terminator with a variable frequency drive, it is important to adhere to tap rules. These rules are designed to ensure that current is distributed evenly across all three phases of the motor. Failure to comply with these tap rules can result in motor overheating and premature failure. It's crucial to understand that you cannot simply connect the Terminator to the motor leads without considering these rules. The Terminator's connection to the motor leads must follow a specific methodology dictated by the tap rules. The tap rules specify the following. Firstly, the tap on the Terminator must be of the same size as the wire connected to the motor leads. Secondly, the taps need to be connected to the motor leads, either in a clockwise or counterclockwise manner. Thirdly, the taps must be spaced evenly around the Terminator. Let's delve deeper into why each of these rules is vital for proper motor operation. Using the correct tap size. The tap size is a critical factor in ensuring proper current flow. If the tap size is smaller than the wire connecting to the motor leads, it creates a bottleneck, increasing resistance. This increased resistance leads to heat generation at the tap point, potentially damaging the Terminator and the motor leads. It can also cause an imbalance in current distribution among the phases, leading to uneven heating within the motor windings. This uneven heating reduces the motor's lifespan and can cause premature failure. Conversely, using a tap size that is too large can also be problematic. While it might not directly cause overheating, it can create a loose connection if not properly tightened, leading to arcing and eventual failure of the connection. In some instances, the oversized tap can work loose over time, causing a bad connection. Clockwise or counterclockwise connection. The direction of connection, either clockwise or counterclockwise, is essential for maintaining consistent electrical characteristics across all phases. In three-phase systems, the phases are 120 degrees apart. Connecting the taps in a consistent direction ensures that the impedance and inductance are balanced across all phases. If the connection direction is inconsistent, it can introduce imbalances in the magnetic fields within the motor, leading to increased vibration, noise, and reduced efficiency. Moreover, inconsistent connections can affect the harmonic content of the current, which can negatively impact the performance of the variable frequency drive and other connected equipment. This also can put excess stress on the motor bearings because of the imbalance. Evenly spaced taps. Evenly spacing the taps around the Terminator is crucial for ensuring symmetrical current distribution. Uneven spacing can lead to an uneven distribution of the magnetic field within the motor, causing localized heating in certain areas of the stator windings. This localized heating can degrade the insulation of the windings, leading to short circuits and eventual motor failure. Furthermore, unevenly spaced taps can create mechanical imbalances within the motor, leading to increased vibration and noise. This vibration can accelerate the wear and tear on motor bearings and other mechanical components, reducing the motor's overall lifespan. By maintaining equal spacing between the taps, you ensure that the current is distributed uniformly, minimizing the risk of localized heating and mechanical imbalances. Bolting the Terminator. After connecting all the taps according to the rules, the Terminator needs to be securely bolted to the motor. This ensures a robust mechanical and electrical connection between the Terminator and the motor. The bolting process typically involves using appropriate hardware such as bolts, washers, and nuts to fasten the Terminator to the motor's terminal box. It is important to taut the bolts to the manufacturer's specified values to ensure a tight and secure connection without over-tightening and damaging the components. A loose connection can lead to arcing and overheating, while an over-tightened connection can strip the threads or crack the Terminator housing. Before bolting the Terminator, it is also crucial to inspect the mating surfaces for any dirt, corrosion, or other contaminants. Clean these surfaces thoroughly to ensure a good electrical connection. Applying a thin layer of anti-seize compound can also help prevent corrosion and ensure easy removal of the Terminator in the future. Additional considerations when working with a 100 horsepower, 480 volts, three-phase motor controlled by a variable frequency drive. There are several additional factors to consider. Firstly, ensure that the motor is properly sized for the application. An undersized motor will be overloaded, leading to overheating and premature failure. An oversized motor, on the other hand, will operate inefficiently and may not provide the required torque at lower speeds. Secondly, select a variable frequency drive that is appropriately rated for the motor's horsepower and voltage. The variable frequency drive should also have adequate protection features, such as overcurrent protection, overvoltage protection, and undervoltage protection to protect the motor from electrical faults. Thirdly, use properly sized conductors for the motor leads and the variable frequency drive input and output connections. The conductor size should be based on the motor's full load current and the applicable electrical codes such as the National Electrical Code, or NEC. Refer to NEC Table 310.15 for ampacities of insulated conductors rated up to and including 2000 volts. Also, it is essential to consider the ambient temperature and the number of conductors in a raceway when determining the appropriate conductor size. Fourthly, provide adequate ventilation for the motor and the variable frequency drive. Both the motor and the variable frequency drive generate heat during operation, and if this heat is not properly dissipated, it can lead to overheating and failure. Ensure that the motor and the variable frequency drive are installed in a well-ventilated area and that there is adequate clearance around them for air circulation. Fifthly, use proper grounding techniques to minimize the risk of electrical shock and to ensure proper operation of the equipment. The motor and the variable frequency drive should be grounded according to the applicable electrical codes. This typically involves connecting the equipment to a common grounding electrode system using a grounding conductor of the appropriate size. Sixth, implement surge protection measures to protect the motor and the variable frequency drive from voltage surges caused by lightning strikes or switching transients. Surge protection devices, or SPDs, can be installed at the service entrance and at the motor and variable frequency drive to divert surge currents to ground, protecting the equipment from damage. Seventh, perform regular maintenance on the motor and the variable frequency drive to ensure that they are operating properly. This includes inspecting the motor windings for signs of damage, checking the motor bearings for wear, and cleaning the motor and variable frequency drive to remove dirt and debris. It also includes testing the variable frequency drive's components to ensure that they are functioning within the specified parameters. Addressing the wire size discrepancy, you mentioned using 1/0 wire to the motor, but the Terminator only has number 10 wire. This presents a significant issue that must be addressed. According to NEC Section 110.3, the equipment must be installed and used according to the instructions included in the listing or labeling. Number 10 wire is significantly smaller than 1/0 wire, and using it as a direct connection would violate electrical codes and safety standards. A proper solution involves using appropriately sized connectors and terminal blocks to transition from the 1/0 wire to the number 10 wire. These connectors must be listed and labeled for the specific application and wire sizes. They should also be installed according to the manufacturer's instructions. It is also important to ensure that the connectors are properly torqued to maintain a secure and reliable connection. One approach is to use a junction box near the motor. Run the 1/0 wire into the junction box and connect it to a terminal block rated for that wire size. Then run number 10 wire from the terminal block to the Terminator. This method provides a safe and code-compliant way to transition between the different wire sizes. Remember, safety is paramount when working with electrical equipment. Always de-energize the circuit before working on any wiring and follow all applicable electrical codes and safety standards. If you are not comfortable working with electrical equipment, consult with a qualified electrician. Variable frequency drive considerations. When using a variable frequency drive to control a motor, there are some additional considerations. Firstly, variable frequency drives can generate harmonics, which are distortions in the electrical waveform. These harmonics can cause problems with other electrical equipment and can also reduce the efficiency of the motor. To mitigate the effects of harmonics, it is important to use a variable frequency drive with built-in harmonic filtering or to install external harmonic filters. Secondly, variable frequency drives can cause reflected waves, which are voltage surges that can damage the motor. Reflected waves are more likely to occur when the distance between the variable frequency drive and the motor is long. To mitigate the effects of reflected waves, it is important to use a variable frequency drive with built-in reflected wave mitigation or to install a line reactor between the variable frequency drive and the motor. Thirdly, variable frequency drives can cause common mode voltage, which is a voltage that is present in the motor's ground wire. Common mode voltage can cause problems with other electrical equipment and can also increase the risk of electrical shock. To mitigate the effects of common mode voltage, it is important to use a variable frequency drive with built-in common mode filtering or to install a common mode choke between the variable frequency drive and the motor. Choosing the right terminator when selecting a motor terminator, there are several factors to consider. Firstly, the terminator should be rated for the motor's voltage and current. The terminator should also be rated for the environmental conditions in which it will be used, such as temperature, humidity, and exposure to chemicals. Secondly, the terminator should be compatible with the motor's terminal box. The terminator should fit securely into the terminal box and should provide a good electrical connection to the motor leads. Thirdly, the terminator should be easy to install and maintain. The terminator should have clear instructions and should be designed for easy access to the terminals. Fourthly, the terminator should be of high quality and should be made from durable materials. The terminator should be able to withstand the rigors of industrial environments and should provide reliable performance for many years. In conclusion, installing a motor terminator with a variable frequency drive requires careful attention to tap rules, wire sizing, and other considerations. By following these guidelines, you can ensure that the motor operates safely, efficiently, and reliably. Remember to always prioritize safety and consult with qualified professionals when necessary. These terminators are designed to provide a safe and reliable connection point between the motor leads and the incoming power conductors. They typically include features such as insulated housings, shrouded terminals, and strain relief mechanisms to protect the connections from environmental factors and mechanical stress. Proper installation of the terminator is essential for ensuring the long-term reliability of the motor. This includes following the manufacturer's instructions, using appropriate tools and techniques, and ensuring that all connections are properly tightened. It is also important to inspect the terminator regularly for signs of damage or wear and to replace it if necessary. Finally, never compromise on safety when working with electrical equipment. Always de-energize the circuit before working on any wiring and follow all applicable electrical codes and safety standards. If you are not comfortable working with electrical equipment, consult with a qualified electrician. By following these guidelines, you can safely and effectively install a motor terminator and ensure the reliable operation of your motor.